Today we are going to discuss on the analysis of the pesticides, the classification of pesticides, sampling, sample treatment and procedure, analysis of the pesticides like the uh, DDT like gamexine, endosulfan, Zeram, nalathon, therum, thiametone, simazine and chloridium. These are the pesticides which are used for the various the, plant protection fruits like. Uh, the sample collection is the is the important is the yeah, for the area collection and the random collection for packaging and transmission of laboratory samples, packaging, sealing, compositing, grinding, mixing, homogenization, and sample storage. These are the how to collect the sample and then to how to packaging, how to storage of the sample, what type of size of the sample. These are the important. The pesticide is a substance which kills a pest. Any substance or mixture of substance which are intended for preventing or destroying or repelling or the mitigating any pest. The insect, rodent, nematode, fungus, weed, the forms of terrestrial or aquatic plant or animal life, virus, bacteria, and other microorganisms. These are the pesticides like the gamexine. The gamexine is hexachloro. These are the gamexine. 6-chloro, ClCl. These are act as a pesticide. Gamexine, hexa, or this is also known as a linden. Is the linden. Okay. This endosulfan, which are chlorine sulfur containing, endosulfan, chloridium, DDT. You know about the DDT is the C 3-chlorine and C like the phenyl, chlorophenyl, and this is the phenyl CH. These are the DDT compound. DDT, gamexine, DDT, endosulfan, chloridium. Okay. Therum. Most of the this therum is a sulfur containing compounds. The structure of therum is therum is again CH3 and sulfur, so thiamine. Yes. Nitrogen, CH3 and CH3. This is known as the theorem. The structure is these are sulfur containing pesticides. Zeram. Okay. Then simazine is used as the herbicides. Simazine, thiametone, sulfur as well as phosphorus containing pesticides. Genium. Okay. This the classification of pesticide is the classification of pesticide is which are the classification classification is natural pesticides and natural and synthetic pesticides, natural and synthetic. In synthetic, there are two types. One is organic and inorganic. These are the types of the inorganic. The organic pesticides, the organochlorines, organophosphates is the organochlorines. That is chlorine containing pesticide like gamexin, organophosphates like malathion, carbamates like sulfur containing uh, and synthetic pyrethroids. These are the types of the pesticides. Uh, this classification of pesticides, the first chemically synthesized or microbial synthesis, botanical and mineral based controls to include the sulfur and lime. Uh, these microbial pesticides agents to stem from bacteria, fungi, algae, naturally occurring viruses or protozoans. The botanical pesticides come from the plants like neem and pyrethrids. Okay. The synthetic pesticides, inorganic pesticides are of the mineral origin, mainly compounds of antimony, arsenic, barium, boron, copper, fluorine, mercury, selenium, sulfur, thallium, zinc, and these elemental phosphorus, sulfur, antimony, potassium tartrate are emetic and their oxides of the inorganic pesticides. Organic pesticides, you know about the DDT, methoxychloro, dieldrin, chlorodane, toxaphene, Myrex, uh, capone, lindane, and benzene hexachloride. The organophosphates, the malathion, methyl, parathion, chloro, pyriphos, the diazonium, dichloros, phosphonate. These are the organic phosphor containing pesticides. Herbicides, dichlorophenoxyacetic acid, ureas. Uh, these are the pesticides which are used in the various purposes, and therefore in these pesticides in micro level as or macro level, the analysis is very important in the pesticides. The various functional type of the pesticides. The one of the pesticides is the chlorinated pesticides. The analysis of chlorinated pesticides, the like DDT. Uh, in DDT is hydrolyzed with sodium hydroxide in medium. 1:1 mixture of methanol and isopropanol or acetone. Under the reflex, when three equivalents of ionic chloride are liberated as per the per mole of DDT. The ionic chloride is estimated by using the precipitation titration method like the uh, Pollard's method or Morse method. This the content is calculated by multiplying the percentage chloride, free chloride with suitable conversion factor. In DDT, both uh, is is in DDT analysis of DDT is analysis of DDT. Okay, in this DDT is RCl. The represented is RCl, and in presence of sodium metal and or sodium hydroxide uh, to give the free chlorines from the, or that means the DDT is decomposed and to liberate the free chlorines in by metallic sodium or high concentration of sodium hydroxide is used in the methanol and acetone solvent mixture. Okay, and this one of the chlorine is estimated. One chlorine is estimated is to form NaCl and Ag. This to NaCl is liberated. This NaCl is liberated, and this NaCl by using Hollard's method or Morse titration method, precipitation titration method, this NaCl is titrated with AgNO3, silver nitrate, and to give the white PPT of silver chloride, AgCl, white PPT, and silver nitrate, NaNO3, sodium nitrate. And by using this silver nitrate, excess is using the potassium chromate as an indicator. Okay, K2CrO4. And this K2CrO4 again with excess of silver nitrate to form Ag2CrO4. This is the yellow PPT to form a yellow PPT. This is the most titration method. And Bullard's method by using the potassium thiocyanate and used as a ferrous ammonium sulfate by using Bullard's method. Okay, this in detection analysis of DDT very accurately but not exactly. Very accurately but not exactly. 1 gram of the DDT. Let us take 1 gram of DDT, and in DDT is taken in 250 ml volumetric flask. Is then add 125 ml mixture of solvent, like isopropanol or methanol and acetone, to make the mark with methanol, and in round bottom flask to the 50 ml alucard, the pipette out the 50 ml alucard and 50 ml 3 normal aqueous solution of sodium hydroxide is added and replenished for 1 hour. Take the 50 ml volume of the solution and then add 50 ml sodium hydroxide solution and reflux on water bath for an about 1 hours. Alright. After 1 hours, after reflection, 1 hour, in presence of this solvent and sodium hydroxide, the DDT is the chlorine containing compound. The one of the chlorine is the decomposed or liberated, and this liberated chloride is react with or to form a salt like the sodium chloride, and this sodium chloride is important for the analysis of DDT. And after cooling, add 5 ml hydrogen peroxide 30%. Then add hydrogen peroxide. After cooling, add 5 ml hydrogen peroxide and gently boil for 10 minutes. If it is still colored, repeat the above this process. Destroy the excess of alkalinity by using nitric acid and phenolphthalein. Why that is to due to sodium hydroxide more basic in nature of the solutions, and therefore to neutralize the solution or alkalinity by using the nitric acid. Okay, then add the excess of 10 ml of nitric acid in the this mixture, and then to dilute the solution in the known volume of the flask, and then add 20 ml standard solution of silver nitrate. Okay, and after volume to dilution, okay, then pipette out the pipette out or pipette out the known volume of 10 or 25 ml solution, then add standard solution of 25 ml silver nitrate AgNO3 in this solution, AgNO3. Okay, then 5 ml nitrobenzene, 1 ml ferric alum, that is ferrous aluminum sulfate indicator, and this APS, additional APS and benzene. Okay, benzene. Why use benzene? Because this precipitate of benzene, precipitate of silver chloride is adsorbed on the benzene droplets, and you get the clear solution. And therefore, without removing the precipitation, you can also use the benzene solvent in this titration. And this solution is titrated with the potassium thiocyanate, and to give the brick red color. This is the analysis of the method. To carry out the blank titrations with the same the 50 ml alucard stock solution without hydrolysis of the that is the potassium thiocyanate, then add blank titration potassium thiocyanate, then ferrous aluminum sulfate, 2 to 3 drops of benzene, okay, and silver nitrate, okay, then titrated with the silver nitrate and ferrous aluminum sulfate and titrated to potassium thiocyanate. This is the difference in between black and blank reading. You can calculate the concentration of the or total amount of blank. The is the 1000 ml calculation is the 1000 ml one normal, 1000 ml one normal. The silver AgNO3 is equivalent to the is equivalent to 34.9 gram of DDT. Also DDT. Okay, that ZmL of ZmL means X minus Y is blank titration is Z ml of the normal solution is correspond to the 34.9 into Z into normality of normal solution of silver nitrate upon 1000, and then percentage into the percentage of DDT, into 34.9 into Z into N into 100 divided by 1000 into W. You get the percentage of DDT. You can calculate the percentage of DDT. Okay, thank you.